Hey guys, we get to do the last part of 4 today. So I kind of had ended the last one talking about conjugates. And what a conjugate is, it's going to be when I take something and basically just switch the middle sign. So for example, I'm going to be looking at these numerators down here, and the conjugate of that is going to be, let's get my pen there, 3 minus 5i. Notice that the only thing I changed is this little sign right there. As you are doing this though, because these are complex numbers, we're going to call these complex conjugates. Okay? You might write that down. It's a good vocabulary word. Complex conjugates. What I'm going to do to simplify a number, I can't have any imaginary numbers in the denominator. So what I'm going to try is multiplying. Let me write the original problem down real quick. I'm going to try multiplying by the complex conjugate. And so what that's going to look like is I'm multiplying by the fraction 3 minus 5i. And if I'm going to keep the fraction's integrity the same, meaning I don't change what it's actually worth, then I need to do this to the top as well. And the reason I'm choosing to do this is check out what happens on the bottom. I have a binomial times a binomial, which means I get to use my favorite four-letter F word, FOIL. And so now I have 3 times 3, which is 9. And 3 times negative 5i, which is 15i, negative 15i. And positive 5i times 3 is a positive 15i. And last but not least is a negative 25i squared. And on top, I'm just going to distribute negative 6i plus 10i. Now in the bottom, do you notice my middle two terms? Notice that they will cancel. That's why you use a conjugate, is to make those cancel. And of course this, I notice, is actually negative 25 times negative 1, because I squared is just negative 1. So what I really have on the bottom is 9 plus 25, which is, oops, not 36. Try 34. Oh, whoops, that was an I squared, wasn't it? Which means that that should be 10 times negative 1, which is actually minus 10. And then two things. When you simplify, I notice that like 6, 10, and 34 can all evenly divide by 2. So that's going to be a negative 3i and a negative 5, and then what, 17? And then I also remember that when it comes to complex numbers, I really like writing the real number first. So I'm going to do negative 5 minus 3i being divided by 17.